Hello friends, today we will discuss about the transportation problem. So in transportation problem, we have different cases. So we will talk in detail about the transportation problem in today's class. So first we will talk about the introduction of transportation problem. In the introduction of transportation problem, we have either balanced transportation problem and unbalanced transportation problem. So first we will talk about the balanced transportation problem, then we will go for the unbalanced transportation problem. So in the balanced transportation problem, if the supply is equal to the demand, we will say that that is the balanced transportation problem. And if the supply is not equal to the demand, then we will say that this is a case of unbalanced transportation problem. So either supply is more than demand or supply is less than demand, we will say that this is the unbalanced transportation problem. So we have discussed here right now about the balanced and unbalanced transportation problem. So if we have a case of balanced transportation problem, so we will solve the problem directly. If we don't have the case of balanced transportation problem, we have to do some process, we have to do some steps. So if we have, let us assume we have a case of unbalanced transportation problem. So we have either supply is more than demand or supply is less than demand. So if we have supply is more than demand, then what we will do? We will introduce a dummy market, and that market will have zero transportation cost. So in the other case, if we have supply is less than demand, so what we will do? We will introduce a dummy factory, and for that factory, we are supplying the demand from that factory. We are supplying the demand, and we are introducing zero transportation cost with that particular factory. Next, we will discuss about the solution of transportation problem. So in the solution of transportation problem, we have two things. One is we have to find the initial basic feasible solution. So we will find the initial basic feasible solution, and then we will go for solving the problem for optimal solution. So first we will find the initial basic feasible solution, and then we will go for finding the optimal solution of the given problem. So for finding the initial basic feasible solution, we have three different cases. One case is northwest corner method. Another case we have least cost method, and last one we have Vogel's approximation method. So for solving the transportation problem, we have three different cases. One case is northwest corner method. Second case is least cost method, and third one is Vogel's approximation method. So if we have initial basic feasible solution, then we'll go for finding the optimal solution of the given problem. And for finding the optimal solution of the given problem, we have two different techniques, two different methods we have. One technique is modified distribution method, and another technique we have stepping stone method. So in this lecture, we will talk about in detail about the northwest corner method, least cost method, and Vogel's approximation method. So first we will start with the northwest corner method. For understanding of the northwest corner method, we will go with one problem, and problem is listed below. So here we are talking about the problem. So problem is, for the given problem, we have to find the optimum transportation schedule and minimum transportation cost. So this is a transportation problem. So first thing we have to do is we have to check either the given transportation problem is balanced or not. So in this case, we have these things. We have transportation cost. So there are three demands and there are three supplies. So the demands are 55 units, 65 units, and 75 units, and respectively supplies are 75 units, 95 units, and 25 units. So if we will add these three and these three, so we will get the same. So if we will add these three, it will turn into 195, and if we will add these three, we will have 195. So we will say that from this we can say that both are equal. So we will say that this particular problem is balanced transportation problem. So this is the case of balanced transportation problem. So now we will start solving this particular problem by making use of northwest corner rule. So here we have three different demand, three different supply, and we have different 3x3 transportation cost matrix. So we have different 3x3 transportation cost matrix. So we have in this question we have to minimize the transportation cost. So how we can minimize? We will talk about that. So for minimizing the transportation problem, what we will do? We will solve the problem in two different stages. In first stage, we will find the initial basic feasible solution, and then we'll go for the optimization of the problem. So for finding the initial basic feasible solution, we will make use of northwest corner rule. So in the northwest corner rule, so this is a given problem we have. So we'll solve this particular problem by making use of northwest corner rule. So in the northwest corner rule, we know that we can plot the northwest corner by this way. We are plotting the direction of north, south, east, west like this. So this is the northwest corner. So this is the northwest corner. So we will start the allocation of the problem by northwest corner. So we will allocate from this. We will start allocating the problem, allocating the cell from this. Means allocating the cell means we have a 75 units of supply over here, and we have 55 units of demand over here. So there is a demand of 55 units, but there is a supply of 75 units. So we will fulfill the demand by giving the supply, and we will allocate the minimum value out of these two. So we have minimum value 55 units out of 75 and 55. So we will allocate 55 units in this cell. So since this particular cell got satisfied, so we will cross this cell. So like this, we will advance further. So we have on the northwest corner, we have 55 unit allocation in the S1D1 cell. So next we will start with the further allocating the cell. We will start allocating the cell in the further. We will allocate further values. So we have allocated 55 in this case, in this cell. So other two cells get crossed out. Next we have northwest corner, this particular corner, S1D2 is the next northwest corner. So we will allocate, we will start allocating in this particular cell. So remaining amount of supply is there of 20 unit, and this particular demand is fulfilled. So there is a demand of 65 units for this particular cell, but there is a requirement of there is a supply of only 20 units. So what we will do, we will supply 20 units in this cell. So this particular cell get crossed out. So we consider this particular row is also satisfied. So next we have a requirement of a demand of 45 units for this particular cell. Next northwest corner, we have this particular corner, northwest corner. There is a demand of 45 units, and we can supply up to 95 units. So what we will do, we will supply 45 units in this particular cell. So this particular column is also satisfied. So we will cross this particular cell. Next we have the remaining values for this particular supply is how much we have supplied 45 units. So we have 50 units. So in this particular cell, there is a demand of 75 units, but we can maximum supply is 50. So we can allocate 50 for this particular cell, and remaining 25 we can get from this particular supply. So like this, we can fulfill the supply and demand, and we will starting with the northwest corner. So that's why this technique we have northwest corner rule. So we have 20 units, we have crossed it out, and we have next 45 units, and finally we have 50 and 25 units. So we have started with the northwest cell, and first we have moved to horizontal direction, and then we have moved to in the vertical direction. These are the two main steps in this particular solution, in this particular method. Next we will find the transportation schedule. So we can find the transportation schedule is S1D1 is 55, S1D2 is 20, S2D2 is 45, S2D3 is 50, and finally S3D3 is 25. We can also find the transportation cost. We can find the transportation cost by this way. So we have transportation cost here. So we have transportation cost here. Transportation cost is 55 into 18 plus 20 into 21. So we are multiplying these values 55 into 18 plus 20 into 21 plus 45 into 22 plus 50 into 26 plus 25 into 60. So finally, we are getting a transportation cost. Total transportation cost is the 4,100. So this particular solution we have received, we have achieved from by making use of northwest corner method or northwest corner technique. Next technique we have, and that particular technique is the least cost method. So the same problem, we'll solve the same problem by making use of northwest. Right now we have used northwest corner rule. Next we'll solve this same problem by making use of least cost method. So we'll start with the same problem and we'll solve the given problem by making use of least cost method. So in this technique, what we will do, we'll scan the entire transportation cost. So we will scan the entire transportation cost and we'll find the minimum transportation cost. So in this case, we have two values of minimum transportation cost, 15 units and 15 units. So if there is a tie, so in the entire transportation problem, if you are getting tie, so we can break the tie arbitrarily. So if in the entire transportation problem, if you are getting any tie, at any point of time, if you are getting tie, so we'll break the tie arbitrarily. So we can select anyone. We can select anyone, either this or this. So if you are selecting this, so in this particular cell, we have requirement of 65 minutes and there is a supply of 25 units. So what we will do, we will supply here 25 units. So this particular cell is satisfied. So we will cross this particular cell. So in this case, we have 25 units of allocation for this particular cell. Next, we will go for again, we will scan the list cost. We will scan the list cost. So we will find the list cost. So next list cost is again 15 units. So we will start allocating in this particular cell. In this case, in this particular cell, there is a demand of 75 minutes and there is a supply of 75 minutes. So we can supply 75 units in this particular cell. So either we can cross the supply this particular row or this particular column. Better we will not cross both the row and column at a time, because here it will not give any problem. What if we will talk about the next method, we have Vogel's approximation method. So in that particular method, there will be an issue. So we'll talk that particular issue in the next slides or next coming slides. So right now we are crossing this particular column. So we have satisfied this particular column. So there is a demand of 75 units and there is a supply of 75 units. So we have allocated 75 units in this particular cell. Again we'll scan the list cost. So next list cost we have 16 units. 16 is the again next list cost. So we will start allocating this particular cell. So in this case, in this cell we have demand of 55 units, but there is a supply of 95 units. So we locate the minimum value and the minimum value is the 55. So this particular cell is also, this particular column is also satisfied. So we will cross this particular cell. So remaining quantities here, remaining quantity is the 40 units. So 48 units is the remaining quantity. Now we will again scan the remaining transportation costs. So we have 21 and 22, two transportation costs. So minimum we have 21. So we cannot supply any because there is no supply. So we will cross this. So next minimum value we have, next minimum transportation cost is 22. So we will allocate in this particular scale the remaining 40 units. This is the 40 units. So we can say that this particular column is also satisfied. So by this way we are using the least cost method to allocate the supply and demand, and we'll find the initial basic feasible solution of the transportation problem. So again, we are scanning the list cost, we are supplying, we are fulfilling the cell. So like this, we are fulfilling the cell. So we have two steps in this case. We have to scan the transportation cost, and we have to start from the least value of smallest value of the transportation cost. Again, we will select the least cost from the uncrossed cell and unallocated cell. So we have mainly two main steps in this particular case. So we will find the next. We will find the transportation schedule, and we have this is the transportation schedule: S1 D3, S2 D1, S3 D2, and S3 D3 and D2. S3 D2. So we have this is the transportation schedule. We have, and next we have we have to find transportation cost. So we can find the transportation cost by multiplying this 55 into 16 plus 40 into 22 plus 25 into 15 plus 75 into 55. So we can find transportation cost by multiplying these values, and we are getting the transportation cost. We are getting the initial feasible solution of transportation cost. Initial feasible solution of the transportation cost as the 3,260 by making use of least cost method. So by using northwest corner rule, we have 4,100, and by making use of least cost method, we have 3,260. So we can say that if we are comparing the least cost method and northwest corner method, so we can say that least cost method we are giving the better solution compared to the northwest corner technique. So next we will talk about the Vogel's approximation method. So we have next techniques, and that technique is the Vogel's approximation method. So we will make use of Vogel's approximation method, VAM method, for finding the initial basic feasible solution. And in this case, we will also make use of the same problem. We will take the same problem and we will find the initial basic feasible solution of the same problem by making use of Vogel's approximation method. So we'll find the solution, initial basic feasible solution of the given problem by making use of Vogel's approximation method. So what we will do in this case? So we will scan the least cost. So like the least cost method, we will scan the least cost and second least cost in the row and column. So what we will do, we will scan the least cost in this case. So we have least cost is, so we will scan the least cost in row or column. So we are scanning the least cost in this particular column. So in this case, we have least cost is 16 and next least cost we have is 16. So what we will do, we will find the penalty for this particular column. So for this particular column, we will find the penalty, and we are finding the penalty by making use of this particular formula. So we are finding the penalty by using this particular formula. So we will find the penalty by next smallest minus smallest, means this 16 minus 16. So 16 minus next smallest is the 16 and smallest one is the 16. So we will find we have a penalty of 0 for this particular column. We have 0 penalty. So we have 0 penalty. We have 0 penalty for this particular column. So we will find the penalty for each row and for each column. So if we will talk about the penalty, value of penalty for this particular row, so we have penalty. In this case, we have 15 is the least cost and next least cost is 18. So we have a penalty of 3. Like that, we have a penalty of 16 and 22. So 22 minus 16 is 6. So we have different penalties for each row and for each column. So we are finding the first step. What we are doing in the Vogel's approximation method is the finding the penalty. So we have found the penalty for each row and for each column. So for each row we have penalty. These are the penalties for respective rows and these are the penalties for respective columns. So what we will do, we will select the maximum penalty. So we have two different values of maximum penalty, 6 and 6. Earlier also I have said that if there is a tie, we have to break the tie arbitrarily. So we can break the tie arbitrarily. We can select any one. So if we are selecting this particular 6, if we are selecting this 6, so what we can do? So if we are selecting this 6 as a as a maximum penalty. So if we are selecting this particular 6 as a maximum penalty, so what we'll do, we have selected this particular 6 as maximum penalty. So if you are selecting this 6 as maximum penalty, so we are selecting this particular column. So in this particular column, so list cost is the 15. So we will select this particular cell. So in bogus approximation method, what we are doing, we are finding the initial basic feasible solution. Initially, we are finding the penalty for each row and for each column. So we are finding the penalty for each row and each column. So these are the penalties for column and these are the penalties for row. And we are selecting the maximum penalty. And if there is a tie in the penalty, we will break the tie arbitrarily. So if we have selected this particular 6 as a penalty, maximum penalty, then we'll go for this particular column. And in this column, we have list cost is the 15. So 15, we have list cost. So we have selected this particular cell. Again, if we have selected this particular cell, then we will go to the allocating the cell in the same way we have allocated the cell in the northwest corner rule and in the list cost method. So we are going to select, we are going to allocate the cell. So in this cell, there is a demand of 25 units and there is a supply of 65 units. So we will allocate 25 for this particular cell. So we have allocated 25 units in this cell. So this particular row is satisfied. So we will cross this particular row. Since these rows got satisfied, so we are crossing this particular row. Again, what we will do, we will find the penalty. So since this particular row is satisfied, so we will cross this particular row. Again, what we will do, we will find the penalty. So again, we are going to find the penalty, and how we are finding the penalty, we will see. So again, we are going to find the penalty, and how we are going to find, we will see how we are finding the penalty. So the next penalty for this particular column is, for this particular column, we have 26 minus 15. So this is 11. Again, for this particular column, we have 22 minus 21. So we have 1. And for this particular column, 18 minus 16. So we have 2. So for this, for each row and for each column, again, we are finding the penalty, and we have the penalties for each row and each column are, these are the penalties for each row and each column. Again, we are going to select the maximum penalty. So in this case, the maximum penalty we have is the maximum penalty we have is 11. So we have selected this particular 11. So we will go for this particular column. So in this column, we have list cost is the 15. So we will start allocating this particular cell. In this case, in this cell, there is a demand of 75 and there is a supply of 75. Demand of 75 and supply of 75. We have allocated 75 in this particular cell. Again, this cell is satisfied, so we can cross the cell. So we have second time selected the penalty, maximum penalty, and we have selected and we have allocated 75. And since this particular column is satisfied, so we are crossing this particular column we are crossing. So since this particular column got satisfied, there is no any vacant cell. So we have crossed this particular, we will stop finding the penalty for this particular column. Again, we'll find the penalty in the same way like earlier, and we'll find the penalty for each row and for each column. So for next time, we have penalty for row and for column is like this. So in this case, we have penalty for this particular row is 3 as it is, or like earlier one, and 6 for like earlier one, 22 minus 16 is 6. But in this case, we have this, say this column is crossed. So for these two columns, we have 2. 18 minus 16 is 2, and for this 22 minus 1 is 21 is 1. So again, we'll select the maximum. We'll select the maximum penalty, and in this case, in the third iteration, we have maximum penalty is the 6 units. So we have selected this particular. Row. So we are going to select this particular row, and so for selecting this row, what we have to do, we have to we have to allocate. So in this particular row, we have minimum transportation cost, least transportation cost is 16. So we will select this particular cell. In this cell, we have there is a demand of 55 units and there is a supply of 95 units. So we will start 55 units, supplying 55 units in this particular cell. So we have allocated 55 units in this cell. So we have allocated 55 units in this cell. Again, we will see the, since this particular cell is, this particular row is satisfied, so we will cross this particular column is satisfied, 55 is satisfied, so we'll cross this particular cell since this is satisfied. Next, what we will do next, we have, there is no any requirement of for this particular cell because there is a 75 units and we have already supplied the 75 units over here. So we'll cross this. So remaining quantity, that is the 40 units, will be satisfied. We will allocate in this particular cell. So like this, we are allocating the cells by making use of Vogel's approximation method. So like this, we are allocating the cell by making use of Vogel's approximation method. So in the same way, we have different steps. What are the steps we have followed? We will list over here. So those steps we have followed, we will list over here. So these are the steps we have followed in this case. These are the steps. What we have did is we have calculated the penalty for row and column. Again, then we have selected the row or column having the largest penalty, and if there is a tie, we have to break the tie arbitrarily. Next, we have the transportation schedule. This is the transportation schedule, same what we have obtained from the least cost method, and same transportation cost we have obtained. This is the same transportation cost we have obtained from the least cost method. So with this, we have discussed all these three methods for finding the initial basic feasible solution, and these methods are northwest corner rule, least cost method, and Vogel's approximation method. So we will stop over here and we will talk about the optimization of we will talk about the optimization of initial basic feasible solution by making use of Modi's method, modified distribution method, in the next class. Okay, so we will stop over here. Thank you.